Good morning to everyone. I am M.JAYASRI, Assistant Professor, Department of B.VOC Marine, A.D.M. College for Women, Autonomous, NAGAPATTINam. Now let us see about the topic is seaweeds. Learning objective of seaweeds. After completing this chapter, learner should be able to become familiar with seaweed polysaccharides, the type of the seaweeds that are potential sources, understand the structure, understand their use for food and other applications. Introduction to seaweeds. Seaweeds is the common name for countless species of marine plants that grow in the oceans as well as in river, lakes and other water bodies. Seaweeds are also called a marine algae. Some biologists prefer the name microphytes or macroalgae. Seaweeds have a leaf-like fronds and hold fast in the place of the roots. This is the example of the seaweeds. Some examples are marine algae that are spirulina, Irish mosses, Geridium, Gracilaria, Sargassum, Ulva and etc. They reproduce asexually. Seaweeds are particularly important ecologically. They dominate the rocky intertidal in most oceans and in the temperate and polar regions cover rock surfaces in the shallow subtidal, although only penetrating to 8 to 40 meter in the most oceans. Some are found to depth of 250 meter in particularly clear waters. Most seaweeds, although some are parasitic to other seaweeds. Seaweed species such as kelps provide an essential nursery habitat for fisheries and other marine species and thus protect the food sources. Other species such as planktonic algae play a vital role in capturing carbon, producing at least 50% of its oxygen, transform solar energy into the chemical energy in the form of organic matter, produce oxygen for organisms both on land and in the oceans. This is the multicellular algae. Multicellular algae, it is a most familiar type of the marine algae. Take structure, type of pigment and stored food product into the consideration. Like highly specialized structure and reproductive mechanism like terrestrial plants and vary in a shape and the size. Land plants. This is the sum of the example of algae classified by the cellular structure and the habitat. Land plants, all members of multicellulars, and the chlorophysin algae, they are some members multicellular, some is a unicellular. Cyanoflagellates, they all of member unicellular or a colonical. Diatoms. Diatoms are most members unicellular or rare arboreal species. Structure. Seaweeds appearance somewhat resembles non-arboreal terrestrial plants. Thallus, the complete body of a seaweeds. Then the lamina. Lamina is nothing but a flattened structure that is somewhat a leaf-like. Sorus. Sorus is a spore cluster. On fucus, air bladder is a present. On kelp have a float assist organs. Stipe. Stipe is a stem-like structure, may be absent. Holdfast. Holdfast is specialized basal structure providing a attachment to a surface, often a rock or another alga. Haptera. Haptera is a finger-like extension of the holdfast anchoring to bending substrate. This type and holdfast usually lack tissues specialized for water and nutrients transport. Type of the seaweeds. The algae are three types, namely green algae, chlorophyta, brown algae, phaeophyta, red algae, rhodophyta. Not always easy to recognize visually because of the pigment proportion. Primarily limited to area of shallow water and rocky shores. First we see about green algae. Green algae is most live in a freshwater and terrestrial environments. The group from which embryophytes. Higher plants emerged. Only 10% are marine. Most have a simple thallus. Pigment and food resource are the same as terrestrial plants. Green algae examples Enteromorpha, sea lettuce and Ulva and Valonia. Thallus. Ulva is a green algae included in the class Chlorophyceae. It is commonly called sea lettuce. All species are a marine. They are found attached to the rocks and kelps. Brown algae. Brown algae is most prevalent type of the seaweeds. Brown or yellow brown in color. Brown algae are found in the water of the both temperate or arctic climates. Seaweeds can thrive in the both salt and fresh water, but the brown algae, known as a kelp, grows in only in salt water, most often along a rocky coastlines. Some examples of brown algae: Fucus sargassum. Sargassum is a brown algae. It is a marine alga. It is a seaweed. It is commonly called a gulf weed. It is included here under the classes Phaeophyceae. The plant is diploid sporophyte. Now see about the red algae. Red algae. There are more than 6,000 species of the red algae. Red algae gain the often brilliant colors thanks to the pigment phycoerythrin. The ability of observe the blue light allow red algae to live at the greater than either brown or green algae. Very few of the 4,000 species live in freshwater or soil and inhabited most shallow water marine environments. Red algae examples: Palmaria, Chondrus, Gracilaria. Gracilaria is a red alga. It is a marine. It is the attached form. It is found either attached to the rock or mud in the seas. It is an agoraphytic. Then the plant haploid gametophyte. It is the dominant phase. It grows up to 50 centimeters height. They are independent plants. Now see about the seaweeds polysaccharides. Significant amount of seaweed polysaccharides are used in food, pharmaceuticals and other products for the human consumption. Commercially important are agar, agarose, carrageenan and alginic acid. Agar is a polymer made up of subunit of the sugar galactose. The word agar comes from the Malay word agar meaning a jelly. It is also known as a canton or agar, Ceylon agar. Structure: it is an unbranched polysaccharide obtained from the cell wall of some species of red algae or a seaweed. Agar polysaccharides serve as the primary structural support for the algae cell walls. Uses of the agar: the agar gels are not liquefied by the organism that digest gelatin and are very valuable as a supporting agent in bacterial culture media. Agar is non-digestible and is at the times given to provide a bulk to the phases in the treatment of the constipation. It is also used as a laxative, a vegetarian gelatin substitute and a thickener for soaps, in jellies, ice cream and clarifying agent in the brewing. Next, the agarose. Agarose is a heteropolysaccharides generally extracted from the certain red seaweeds. It is a linear polymer made up of repeating unit of the agarobiosis, which is a disaccharide made up of D-galactose and 3,6-anhydro L-galactopyranose. Then agarose is one of the two principal components of agar and is purified from the agar by removing the agar's other component agaropectin. Agarose is a non-toxic and has several properties and a specification that make it useful as a gelling agent in many applications such as nucleic acid, electrophoresis, immunodeficiency techniques, gel plates or overlays for the cells in tissues culture, cell culture media, gel chromatography, affinity chromatography and ion. Agarose is frequently used in molecular biology for the separation of large molecules, especially DNA, by electrophoresis. Slabs of the agarose gel, usually 0.7 to 2% for electrophoresis, are readily prepared by the pouring the warm liquid solution into a mold. A wide range of the different agarose varying molecular weights and properties are commercially. Next, the carrageenan. Carrageenans are polysaccharides that are extracted from the red edible seaweeds. All carrageenans are the high molecular weight polysaccharides made up of repeating galactose units and 3,6-anhydrogalactose, both sulfated and non-sulfated. The units are joined by the alternating A13 and B14 glycosidic linkage. There are three basic types: lambda-carrageenan, kappa-carrageenan and lambda-carrageenan. This is the food is made by the carrageenan, gelling agents, thickening agent, protective coatings and fat substitute and a stabilizing agent. is in the presence of calcium. Lotta-carrageenan are the forms of a soft gel and kappa-carrageenan forms of a stiff and brittle gel. But in the presence of potassium salts, kappa-carrageenan forms a very firm and elastic gels. Carrageenan as an additive used to thicken, emulsify and preserve the food and drinks. It is a natural ingredient that comes from red seaweed, also called a Irish moss. It is one of the red seaweed. You will often find this ingredient in nut milks, meat products and yogurt. Then alginic acid. Alginic acid is also called a algin. It is the natural occurring edible polysaccharide found in a brown algae. It is a hydrophilic and forms a viscous gum when hydrated. With metals such as the sodium and calcium, its salts are known as alginates. Its color range from the white to yellowish brown. Alginic acid is also called a algin. It is naturally occurring edible polysaccharide found in a brown algae. Alginic acid can absorb the 200 to 300 times its weight in a water and solids at a low pH yielding a high viscosity, high pH gel. This form a physical barrier floating in the gastric acid contents, reducing a acid reflux into the esophagus. It is useful for treating gastroesophageal reflux disease and indigestion. Then alginic acid is often combined with aluminum hydroxide and magnesium carbonate to form the antacids. The combination of the alginic acid, aluminum hydroxide and magnesium carbonate is used to treat the symptoms of stomach ulcers, gastroesophageal reflux disease, GERD, and other conditions caused by the excess stomach acid. Application of the alginates. Alginates are used to coat fruits and vegetables as a microbial and viral protection by the product and as a gelling, thickening, stabilizing or emulsifying agent in food factories. Now see about seaweeds cultures method. Seaweed culture or kelp farming, the practice of cultivating and harvesting seaweed. Seaweed are culture in a two method. The methods are pond culture and a field culture. In its most advanced form, it consists of fully controlling the life cycle of the algae. Okay, the agar yielding algae are called agarophyte, example Gracilaria, Gelidium, etc. The algin yielding algae are called alginophytes. Collection of seaweeds from the natural habitat is called a capture fisheries. Culture of seaweed is called a culture fisheries. Pond culture. The culture of seaweed in a constructed marine ponds is called a pond culture. This method is practiced in Taiwan. The area recorded is about 1 hectare and there should be inlets and outlets for the seawater. Salinity for a 25 to 35% and depth for a 70 cm. It also needs a muddy bottom. It is dried for a few days before filling the water. Seeds are chopped. The seeds Gracilaria collected from the sea or previous culture. Harvested for every 20 days. The harvesting algae are washed and dried. Then field culture. Field culture is practiced in India. Nylon ropes are tied on vertical poles as long line immersed in a seawater. Chopped Gracilaria pieces are inserted in the ropes at regular intervals. Seaweeds are harvested after 90 days. The another technique is bamboo raft technique. In the bamboo raft technique, characteristics uses a long sticks 1.1 to 1.5 meter long, erected on a seabed and arranged wide distance between the rows, used along cedar lines with floats. Advisable for use submerged area with 0.5 to 1.5 meter water depth at spring low tide. Advantages of this method. Good water movement even with light wave action. Seaweed distance from the water surface is constant. Disadvantages of this method cannot be found any on rocky seabed. Supply of stages getting low. Spider web method. The characteristic of this method similar to raft method without bamboo. Advisable for use open bodies of water with depth of 10 to 20 meter, moderately strong waves and water current. Advantages of this method: high yield and greater flexibility, and self-cleaning and environmental friendly. Disadvantages for this method: capital and labor intensive, serious hazard to the navigation. Of the seaweeds. Seaweeds are used for the following purpose. It is used to agar production, then used to the algae production, agaro production, and agaropectin production. The food. Seaweeds are the extensively used as a food coastal people, particularly in East Asia, example Korea, Japan and China. Agar is a user is a food such as the confectionery, meats and poultry products, desserts and beverages and molded foods. Used in jelly, ice cream, bakery products, medicine, the biomedicine and pharmaceutical industries. Alginate are used in a wound dressing and production of the dental molds and have a host of other application. In microbiology research, agar is extensively used as a culture medium. Digenia is used as a medicine to treat goiter. Other uses of the seaweeds. Other seaweeds may be used as a seaweed fertilizer. Seaweed is currently being researched as a potential source of biofuel in the form of the bioethanol. Seaweed is also an ingredient in some toothpaste, cosmetics and the paints. Seaweeds are rich in nutrients such as fiber, iodine and vitamin K, and have been an important source of the food and animal feed. Thank you.